Hello engineers, welcome back. In the previous video, we learned how to implement min heap in C++. In this video, let's look at an implementation of a priority queue. Okay, let's get started. So what is a priority queue? Priority queue is not a new data structure. It is simply an implementation of min heap, or you can say an application of min heap. So priority queue is an application of min heap, kind of a use case of min heap. So it does not use the traditional queue with first in first out, but it is kind of a queue because we are still getting the first element out in min heap, and then this min heap will alter the queue based on the priority. Okay, that's the idea behind a priority queue. So let's take a simple example to understand how this all works. So let's say we are in a hospital. Okay, let's say we are in a hospital and there are a bunch of patients coming in. Okay, and the doctor can only see one person at a time. So we need to have some kind of a system to decide who goes in next, right? So that's the idea of a queue. We need to somehow decide who goes in next. And in a traditional way, we can say that whoever comes in first, that person can go in. That is the FIFO method, right? First in, first out, right? That is the traditional queue system. But in a hospital, there can be emergency situations and there can be non-emergency situations, right? In this scenario, we need to have some kind of a different method to assign the priority to each patient so that the person who needs immediate attention can go in first and the person not needing so much immediate attention can go next, right? So let's say our priority system is like this. So whoever is requiring high priority, they will be given a priority tag of 1, high priority. And then let's say we have two other kinds of priorities, medium and low. Okay, and we can use this system to kind of decide who goes in first. Let's say if this is my queue and people have come in this order, and I need to decide who goes in next, but they all have reported different health issues to me, and now I'm able to assign some priorities to them. Let's say I have assigned priorities like this. Okay, let's say Sam and Jerry are of higher priority and Tom is next and Harry is low priority. Okay, but Harry has come first to the hospital, but does not mean that Harry will go and visit the doctor immediately. Okay, so this way I'm able to decide who will go to the hospital first. Okay, obviously among Sam and Jerry, one of them should go first. Let's say Jerry goes in first. After that, Sam goes to the front of the queue, and then Sam will be visiting next, followed by Tom, and then followed by Harry. We already know we can use min heap for this. Okay, so how will it look like? In a typical min heap, we have seen that we can put numbers like this 1, 2, 3, 4, 5, 6, 7. But instead of putting numbers, we can put names and priorities like a pair, right? So instead of putting a single number, we will now put a pair. For example, if I need to build an array like this, let's say I need to fill my array with these 4 people, and Harry has come first, then Jerry, then Tom, then Sam, right? So let's put Harry first. Instead of putting a number, I'll put the name as well as the priority for Harry. Okay. After this is done, the second person is Jerry. So I will add Jerry to the array, and then I will apply the heapify up algorithm to push Jerry to the front, because one is having high priority and high priority items will go into the front of the heap, and we will extract the first item from the heap anyway. So Jerry will come out first in case doctor is available, right? So after our heapify operation, Jerry is at the front of the heap. In other words, he is at the front of the queue. Okay, and then Tom came in. So we'll add Tom to the back of the queue, back of the heap, and then we will heapify him up. So now the tree is like this. Jerry 1 followed by... Okay, now the tree is like this. Now we need to heapify up from Tom's point of view. But Jerry is already on top. So when we are comparing the parent from Tom's point of view, Tom is already in the right place. So nothing to do. Now we can move on to the next one. Let's add Sam to the heap. After adding Sam to the heap, we know we need to use the complete binary tree property. So we will add Sam here. right? After adding Sam, we need to heapify Sam up. So comparing to parent, Harry must go down now. Okay, now we have our heap like this, and comparing Sam with Jerry, since both are of equal priority, we can keep Jerry on top, so not an issue. Both are getting equal kind of priority, so no problem. So when we are extracting elements from this heap, Jerry will go first, followed by Sam, and because there is no other rearrangement required, Tom will go next, followed by Harry. Okay, so that is how our hospital priority queue system works using min heap, right? So let's see how we can code all this. So I've created a new file called priority queue, but as you know, this is not a new data structure. We just need to alter the min heap to accommodate our changes. So I will directly copy min heap logic here, and we will just keep making changes to our min heap so that it will just work like a priority queue. So what do we need? The only thing we need is, instead of storing a number, we are storing a combination of name and priority. So this is a pair. So we will store a pair of string, which will be a name, and int, which will be the priority, right? So string for name and int for priority. So whenever we are inserting, we will not insert just a number, we will insert a pair. So while inserting, we need to make a change. And whenever we are trying to do some operation with priority, which is in the second part of the pair, we will just use .second to access that. And whenever we want to access the name, we will just use .first to access that. For example, if I want to access the first elements pair, I will say heap of 0.first. This will give me the name Jerry, and heap of 0.second. This will give me the priority of Jerry. That's it. And the rest of the heap logic, heapify up, heapify down, everything remains the same. Okay, we just need to make these alterations to make this work. So let's see, let's go from top. So we created a heap with vector of int. Instead of vector of int, we will need a pair. So for using a pair, we will include the utility library. Okay, with utility library, we can create pairs. So instead of int, this will be a pair of first string followed by int. String will be for name, int will be for priority. Okay. Next, no change in parent function, no change in left, no change in right. And while heapify up, since we are accessing the priority, we are doing some operation on priority, we will simply say priority dot, we will access the priority using .second. Okay, since in the heap, at this index, at .second's position is our priority. Okay, .first is the name, .second is the priority. Okay, and here we are swapping we are swapping the entire pair, so nothing to do here. So heapify up is done. So for heapify down as well, we are doing some operation with priority. So we need to access .second here, 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 and here. .second. Okay, and that's it. No change in heapify down other than this. While inserting, we need to take in two things now. First is a name, second is the key, and while adding to the heap, we need to make pair, which will take in two things, name and priority. So let's rename this to priority. Okay, so instead of adding just a number, we are creating a pair using the make pair function of the utility library, and then we are pushing it to the heap, and the remaining logic is same. And get minimum, there is no change. We are just returning heap of 0, which will return a pair. And while removing no change. We are just replacing whatever pair is at the back of the queue to the front of the queue, to the front of the heap, and then we are doing heapify down. No change. While printing, we need to change. This is not int anymore. This will be a pair. So we can just use const auto, and instead of printing I, we will need to print I dot first followed by I dot second. Okay, in the first we have the name, in the second we have the priority. So that will be print. Now let's remove all this and let's do inserts, h dot insert. Now instead of passing an int, we need to pass in two things. First will be the name. So Harry went in first with a priority of 3. And like before, let's print at every insert. Okay, so Harry went in first. After that, we have Jerry with priority 1. So after Jerry, we had Tom with priority 2. After that, we have Sam with priority 1. So this was our insert logic. Now we can remove as well to see the prints clearly. Removals. So we call h dot remove. Is it remove? Remove min. Remove min, and then we can print it. Let's do this 3 times. Okay, and that's it. Let's run and see. Okay, we need to make one more change because this is for getmin. Since we are returning a pair, this will be pair now. Pair of string and int. Okay, you can ignore these warnings for now. Let's see. So first Harry went in, and then when Jerry came, Jerry went to the front of the queue, and then Tom was added to the queue, and then Sam was added to the queue. So our inserts are working fine. While removing, Jerry came out first, then Sam came, then Tom came, and then Harry is still in the queue based on the priority. Okay. So this is a simple implementation of a priority queue using min heap, right? So using this min heap, we can build different algorithms like a priority queue. We have seen a hospital example, and a similar concept is used in Dijkstra's algorithm as well, where we will use distance between nodes as the weights, and the minimum distance will create shortest paths, and that's how Dijkstra's algorithm uses the min heap and priority queue logic to implement the shortest path logic. Okay, so let's see that in the next video. Okay, thank you so much for watching. If you have any questions, do ask me. The code is always available on GitHub. Please check it out. And do like if you found this video helpful. Do comment if you have any questions or suggestions. Don't forget to bookmark the playlist and subscribe to the channel. Do share it with your friends. Thank you so much for watching. I will see you in the next one. Cheers.